LIGO. And I think
one of my favorite topics.
indeed. So I've been reading a few technical papers on LIGO, and it appears that a lot of physicists around the world are finding some big problems with it.
No.
Specifically, specifically, the biggest problem that's being cited is when they are basically. Well, first of all, let me back up a little bit and give you a little bit of insight into how LIGO supposedly works. Yeah, and we talked about this before, but the part that we didn't talk about is actually the problem that they're having with it. And first of all, they're saying that LIGO is essentially the way that it works is a long time ago in a galaxy far away, we had a couple of black holes that were kind of spiraling together. And when they ultimately kind of came together, they released a gravitational wave of absolutely magnanimous proportions. Okay, that gravitational wave made its way to our galaxy and crossed our LIGO detectors, and then they were supposedly made the claim that LIGO had a positive hit on it. Now, the way that these LIGO detectors work, briefly, is they are saying, and by the way, this has never been proved in any physics class anywhere, because they can't even make a gravitational wave, first of all. But what they're claiming, of course, is that the LIGO facility, which has basically two laser beams being shot down long corridors at 90-degree angles from each other. There's two facilities, one in the northwest, the second one in the southeast. Okay, so what they're saying is happening is that when this gravitational wave arrived here 100 years after Einstein predicted it, by the way, beautiful timing, that it crossed these LIGO detectors, and the long corridors that these lasers are being shot down, right, are a very precise length, right, in each direction. And supposedly what happens, the theory behind it is that the gravitational waves, when they pass through the LIGO facility, they physically alter the actual length of these long corridors that the laser is being shot down. Of course, when that happens, supposedly, there is a phase differential in between the two precisely spaced 90-degree corridors. Okay, and this is then confirmed by another LIGO facility, which is a couple thousand miles away. Well, not only is that complete BS, and nobody has ever been able to produce a gravitational wave of any magnitude that would possibly even give us anything to go by, showing any distortion in the physical object. It just simply doesn't exist. It's complete fantasy, but let's just go with it for a minute. What they're saying the problem is that one of the ways, part of this detection process is a signal that arises out of the noise, okay? And the whole reason why they have two different facilities is because that way any local noises supposedly would be differentiated, or any local influences would be differentiated between the two facilities, right? Thus giving them a clear signal. Well, the problem that they're finding here is that they've run an analysis on the background noise, and lo and behold, the background noise is virtually identical in both facilities. It's so close that it's almost not even worth noticing, right? So they're saying, wait a minute, if they're picking up exactly the same noise, then there can be no differentiation between the two facilities. Okay, so that's basically where they're going with this. So they've got all kinds of people looking at this. They've got this Sabine Hossenfelder, who is a theoretical physicist specializing in quantum gravity and high energy physics. So she writes this. I know, right? So she writes this article basically saying there's big problems with this. This cannot possibly be working the way that they are describing, and basically proceeds through and absolutely debunks it, right? Well, okay,
That's
cool.
awesome.
She's not the only one. So now we go to Cornell University, and the physicists there, James Creswell, Sebastian van Hossiger, Andrew Jackson, Hao Lu, and Pavel Naselsky, also are coming up with precisely the same conclusions. and I will post all of these in the link, that, you know, they essentially are looking at two virtually identical noise backgrounds, and this is not only not supposed to be possible, um, but it completely annihilates the idea of having independent confirmation between the two LIGO sites. So Cornell has basically gone through and their astrophysics department and have blown it away, debunking it. Next, we have another physicist by the name of Stephen J. Carruthers, who, I love this guy, by the way. He is absolutely astounding. He has also kind of well, he did a debunking piece on the principles cosmic microwave background, saying that basically these microwaves that they're detecting actually are coming from Earth's oceans, because, as I said earlier, water not only absorbs microwaves, but it also emits it. But that's another subject. We'll go into that later. So Stephen Carruthers basically goes in, gives a very long and very detailed explanation as to why LIGO cannot possibly have been right. He cites even more problems with it than just the background noise. And again, like I said, I will pull all this in here. It's kind of technical reading, so if you're not technically inclined, just kind of listen to my synopsis, and you'll get the gist of what's going on with it. So he goes through and he completely debunks it, and then yet another one, Miles Mathis, and he's pretty overt about it. We watch lie, L-I-E, go crumble, and exactly the same thing that all the other physicists are saying. So basically, what's happening here is all these physicists from Cornell, from around the world, different universities, are saying, wait a minute, upon further investigation of this LIGO data, it's not adding up. There really is not anything to provide a clear noise differential between the two sites to give them an absolute positive hit on a gravitational wave. Gee, what a surprise.
Right.
So it's beginning to become mainstream. So this whole media frenzy propaganda BS piece that came out over a year ago when we first talked about this is, on the 100th anniversary, by the way, of Einstein's prediction of it, is being completely torn down. What does that tell us? That now tells us that these people, and this isn't just a little doubt. I mean, this completely throws a wrench in it, to the point where it's completely invalid. That's how severe this is, and the mainstream is not going anywhere near it. But the universities, obviously, their physicists, their astrophysics departments are trying to make a name for themselves. But it just seems pretty crazy that a lot of these physicists are coming out saying this is patently impossible, can't be happening. That the indication of a positive hit is absolutely a false positive, and the noise background, among many other factors, debunks this. So what that means then is now we are right back to where we started from. LIGO supposedly was this alleged proof, from a galaxy a long time ago and far, far away, that we had gravitational waves. Now it's been debunked, so we're right back to where we started from. Gravity's just a theory; it doesn't exist, and it's a big lie. So,
well, even what they presented was as evidence was just garbage. The spokesperson, even said that they found basically a blip on a chart, and they convinced themselves that it was gravity waves. And it's funny, you mentioned something earlier, Bob, and you made a really good point. Like, for example, Cavendish found in his experiment that he could generate gravity in his tool shed, right? But LIGO can't detect gravity from the sun or the moon or the earth, or certainly not from their lead balls, right? Or planetary alignments. So they can't detect that sort of gravity. So they have no sort of metric by which to gauge if they did, get a gravity wave hit, which I think the whole thing is preposterous, because gravity's been debunked by umpteen different ways. But for them to say that they've discovered gravity waves and then show you not one but two real computer simulations, which is definitely an oxymoron. Real is something.
Computer simulation, yeah.
It's a real is something, and simulation is the opposite. But yeah, the whole thing with LIGO, I mean, I called them out months ago, and I'm glad to see that there's actual, astrophysicists and stuff going after them. And I would just say that I think that NASA should absolutely be next on the chopping block.
Yeah, I agree. But of course, the mainstream is carefully avoiding this because it completely destroys them and their funding and all this. And we know how the old political good old boys club works on this. It was a lie from the get-go, and it was completely flawed. And of course, a lot of people may or may not know this, but I think it was just barely a month or 2 months before the actual official announcement of the detection of gravitational waves by LIGO. They also had another positive hit, which turned out to be a supervisor which inserted a false positive, supposedly to check and make sure that the operators were, operating it correctly. And they got a little carried away, reported it, and then they had to make a retraction the first time. And then, of course, the second time, on the 100th anniversary of Einstein announcing this, bada bing, we have verified gravitational waves from a galaxy far, far away a long time ago. So it's a joke, and it always has been. So I'm glad to see this hit in the mainstream as well. So
yeah, absolutely. That's absolutely amazing. Like, because the same sort of thing happened last time when it was the Planck satellite with BICEP. They claimed to have detected, I think it was gravity waves as well, and I believe that was also debunked as the cosmic background radiation. Isn't that right?
I believe so. Yeah. Well, it was Stephen Carruthers' take on the CMB. Again, in the principle, we're led to believe that there's a satellite that goes up and actually measured this CMB, but Stephen Carruthers was saying no. What they're actually measuring, this microwave background, is actually coming from Earth's oceans, and he makes quite a case for it. In fact, there's a really good video on it. I don't have it up right now, but he makes an unbelievably good case for it, and a lot of other people are on board with that idea. And that's why I kind of wanted to mention that not only do microwaves absorb radiation, or water absorb microwave radiation, but it also emits it as well. And Stephen Carruthers' position on it, and he does this very, very methodically, says, nope, it's the water. That's what they're picking up in the CMB.
Well, I tend to think that they're mapping the walls 14 billion light years away more than I think. These guys who can't find missing children and can't map the oceans of the Earth, they're mapping the walls of 14 billion light years away. Yeah, right. Yeah, he's probably got a great point.
Funny. And have you guys heard this claim? I've heard it several times by modern science outlets that they claim that we know more about the universe than we do about our own planet.
Yeah, or about the oceans.
Yeah, right.
Yeah, no, they claim that. They say that we know more about the stars and the galaxies and the universe than we do about our own planet, which
of course they do.
I just think is ridiculous.
That's what they got to tell you, though, so you don't realize that they can't even go there. They don't even know what's out there.
Right.
Yeah, they've made up more about the universe than we know about the Earth. Let's put it that way. That's more accurate.
Right. Yeah.
You know what?